A grocer mixes two kinds of nuts that cost $2.49 per pound and $3.89 per pound respectively to make 100 pounds of a mixture that costs $3.19 per pound. How much of each kind of nut is put into the mixture? Before we get started, we need to take a little vocabulary sidetrack. Do you know what a quantity is? Dictionary.com gives the math definition of quantity as something having magnitude or size, extent, amount, or the like. You may be wondering, why do we care about defining quantities so carefully? Well, if you know the meaning of quantity, then you will be able to identify the quantities in this problem. In fact, if you can identify the quantities in any application problem, then it will be much easier for you to set up the problem correctly. Did you get pounds of nuts for one of the quantities and cost in dollars for the other? Now we can organize what we are given in the problem. We have two different types of nuts. To make things easy, let's just call them cashews and pecans. And we have a mixture of these nuts, and all three involve both of our quantities, pounds and cost in dollars. Now we want to write one equation relating the pounds quantity and another equation relating the cost quantity, keeping in mind that the quantities on each side of an equation must be the same. Pounds must equal pounds and cost must equal cost. So, do we know how many pounds of cashews we need for the mixture? Nope, that's what we're asked to find. So we'll represent the number of pounds of cashews with the variable x in the cashew bin. Likewise, we don't know how many pounds of pecans we need. So we'll represent the number of pecans with the variable y in the pecan bin. But we do know that we need 100 pounds of the mixture, so we'll pop in 100 into the mixture bin. Okay, can you write an equation relating the pounds in our picture? Push pause and try to write it yourself. Remember, pounds equals pounds, so we have the number of pounds of cashews plus the number of pounds of pecans equals the number of pounds in the mixture. Now we need to write an equation relating the cost quantity. Remember, cost must equal cost. Careful, your brain may be too far ahead of you and you may want to write something like $2.49 plus $3.89 equals $3.19. But hopefully, if you thought of writing this, as soon as your pencil hit the paper, you thought, wait a minute, that doesn't make sense. You're right, it doesn't make sense. And much of doing math is trying something and then realizing it doesn't make sense. It doesn't make sense because we're not relating cost. Rather, we're adding the price per pound of the cashews to the price per pound of the pecans and trying to make that equal the price per pound of the mixture. So it seems that we need to figure out what the cost of the cashews is and what the cost of the pecans is, and then add those together to get the cost of 100 pounds of the mixture. Maybe you should push pause again and write down an equation relating the costs. Did you write down $2.49 times x plus $3.89 times y equals $3.19 times 100? Notice we have dollars times pounds plus dollars times pounds equals dollars times pounds. We have a system of two equations and two unknowns. It should be pretty straightforward to solve it using substitution. Go ahead and do it. Push pause and then check back to see if you get the correct result. We were able to solve this problem because we took the time to identify the quantities pounds and cost, and then we built an equation for each quantity. Here's another hint. Typically, in the mixture problems, you will multiply two units together in each term of one of the equations. In this particular problem, we multiplied pounds times price per pound in each term of the second equation.